Hello and welcome to my YouTube channel. My name is Nanye Abraham and I'm a graduate of Kwame Nkrumah University of Science and Technology, Ghana, to be precise, Kumasi. I read mathematics in my BSc program and I would like to be your mathematics teacher for today. Today we are coming to learn a topic in mathematics called echelon row operations. Echelon row operations. Echelon row operation is just a system given to you and you are not using simultaneous equation to solve it, but rather using a method of matrices to solve it. And so we have a question here we are going to solve using the echelon row operations. We have a question here we are going to solve. Now a system is given to us. We have 2x minus y plus 3z is equals to 6. We also have x minus z equals to what? 3. And then we have the third equation, x minus what? Y plus z equals to 2. So we name this one our equation 1, our equation 2, and this is our equation what? 3. Now instead of using what? Using simultaneous equation, probably using substitution method, going a long way to solve it, we have a simple way you can solve this by using matrices, and then that is what we call what? Echelon row operations. Now we are going to use from 10 to 15 minutes, and we can solve as many as we can, but if the time do not permit, we only solve the number of questions we think we can. So we are not doing any big introduction here. We are solving and we are into it. Let's go. Now you are having this system of equation and you are asked to solve it. The first thing you need to do is to change it into the matrices form, and changing it into the matrices form is what we call the augmented matrix form. So we are converting this system of equation to the augmented matrix form, and that is what we have here. What we have here is just taking the coefficient of the coefficient of the variables in each system, or in each equation we have in the system. So we have 2 here because in the equation you can see the coefficient of x to be 2. We have minus 1 here because in the first equation, or equation 1, you see minus 1 as the coefficient of 2, and we did the same thing to all the variables, but the values here which we strike a vertical line through is the equal to variables. The equal, after equal to the constants, we see the 632 is what we brought here. Now in echelon row operations, what we are doing is that we are possibly trying to make this matrix an upper triangular matrix. That is what we are possibly trying to do, and then use what we call back substitution method to solve it. Use the method of back substitution to solve it as simple as we can. Now, so what you need to do is that when you are tackling this form of operation, what you do is that you always make sure the first value here, which is 2, the first value should be 1. Now one thing I don't want you to encourage in your solutions when using the echelon row operations method is that you always don't want anything to be fraction. Don't try to solve it in fractions form. It can be solved, but it makes the work very difficult. So what we are doing is that in this form we are exchanging rows. So we want to exchange row 1 with row 2 to make this value here 1. That can make it as simple as it is. So we are changing it. So it will be 1 0 minus 1 3, and we also have what, the row 1 becomes row 2, which will be 2 minus 1 3, and then 6. Yeah, 6. Row 1 becomes row 2, and row 2 becomes row 1. Then we maintain our row 3. Now we realize that the first row, or the first element of the first row, which is this, is now what, 1, because that is what we are solving with reference to. We are solving with reference to that, and wherever you are solving with reference to any element here, try as much as possible you can to make that what, element 1. So like I said we are trying to possibly make this matrix an upper triangular matrix. That is what we are trying to do. It means that we are trying to make all here probably 0, not 0, but probably 0, and then this one 0, so that it can be an upper triangular matrix. That is what we are trying to do. So what you do next is, to make this place 0, you can multiply what, 2 by row 1, subtract it from what, row 2, so that we can get this value 0. We are trying to make this value here 0. So we'll say that our new row 2 will be looking for is equal to, our new row 2 will be looking for is equal to what, row 2 minus 2 row 1. So row 2 minus, multiply 2 by row 1 and subtract it from row 2. That is what we are doing to get our new row 2. Then our new row 3. Now our new row 3, you see that here is 1, so here we are making this value to what, 0. So you can possibly what, will not multiply it by anything. So our row 3 will now be equal to, the new row 3 will now be equal to row 3 minus row 1. Row 3 minus row 1. Please, this is not difficult. Very, very simple. As simple as that. So let's rewrite our first row, 1 0 minus 1 3. Now our second row, which is the new row, is row 2 minus 2 row 1. So this is what, 2. If you multiply 2 by this and you subtract it, it will now be what, 0. So it's just like it is 2. Then multiply 2 by the element here, which is 1. It will be what, 2 minus 2 times what, 1, which will give you 0. And that is what we are looking for. We always want to make, we are making here 0. That is what we are looking for. So we have gotten our what, our 1 there, our 0 there, and then here, so it is what, minus 1 times minus 1 minus 0, because if you multiply 2 by this 0, it will be 0. So 1 minus 0 will be what, minus what, 1. Now if you multiply minus 2 by 2, you get minus 2. Now it will be 3 minus 2. 3 minus 2, it will now be 3 minus 2, which is 3 plus 2, which will give you what, 5. See, it is 3 minus 2 multiplied by minus 1. So it will now be 3, this will now be what, 5. The whole thing will be 5. We have your 5 here. Then the next thing, which is this, it will now be 6, right? If you multiply 2 by this, it will be 6. And so it's what, 6 minus 6 minus 6, which is what, 0, which is 0. So we are moving to our row 3. The third row, we said it is what, row 3, our new row 3 is equals to what, row 3 minus row 1. So it will be what? 1 minus what? 1, which is what? 1 minus 1, which is what? 0. Then the next thing is what? Minus 1 minus what? 0. Minus 1 minus what? 0, which is what? Minus 1. Then this is minus, so 1 minus 1, which will be what? 2, which will be 2. Please, I hope you are getting me. Then the next thing is what? 2 minus 3, which will give you minus 1, which will give us minus 1. And this is our third row. But look at it. We said the next thing we are going to tackle is to make here what? 0. Because since this and this are now 0, we can make here 0, and this will possibly becoming an upper triangular matrix. Not upper triangular matrix, but it is becoming. So the next thing we want to do is to make this value, or in our third row, 0. That is what we are trying to do. So to do that, we have the third row 3, to be something. But to work with, I told you, whatever element we are working in with reference to, you have to make that element what? 1, positive 1, not negative 1. But here, that is the value we are now coming to work with, or the element we are coming to work with reference to, which is negative 1. So what you do is that you make it 1 by what? Multiplying negative through. So this same system can be written this way: 1 0 minus 1 3. Then this will be 0 1. We are multiplying negative through, minus 5 what? 0. Then the third thing will be what? 0 1 minus 2 1. Sorry, minus 1. I can just maintain it this way. Minus 1, like this. Have minus 1. So right now you see that this and this, to make this one 0, you can add this and this to make it 0. So what you do is that our row 3, our new row 3 is now equal to what? Row 3 plus what? Row 2. This is our row 2, this is row 1, this is row 2. So we are using this row 2 and row 3 now. So what you do now is, what you maintain now is, you maintain your row 1. Row 1 is 1 0 minus 1 3. Row 2 is 0 1. You maintain it, minus 5 0. And our row 3 is what we are looking for: 0. It's already 0, and this plus this. Row 1, our new row 3 is what? 0 plus 0 is 0. Minus 5. Now 1 minus 1, 1 plus minus 1 is also what? 0. That is what we are trying to achieve. And then this plus this will be minus 3. Am I sure? Minus 3, yeah, minus 3. This plus this will give you minus 3. Then this plus this will give us what? Minus 1. Minus 1. So from here, what you do is, we call it what? Back substitution. The next method is what we call back substitution. substitution. So the back substitution, what you do is to get the values of maybe x, y, z. You know that this value stands for x, this stands for y, and this stands for z, and this is what it's equal to. So to do back substitution, you just say 3z. So it will be minus 3z is equal to minus what? Minus 1. Now to get your z, we are looking for z. Divide both sides by what? Minus 3. And our z is equal to what? 1 over 3. Now to get y, we now use this equation. To get y, you use that equation or that row, the second row, row 2, row 3, and row 1. We are saying it is back substitution is that we are solving it from the down to the what? The top, and we are getting the higher variable, which is z, before we get y. So the next thing is this is 1x, which is x minus 5y equal to what? 0. Oh, sorry, this is y, not x. So it is what? Y minus 5z is equal to 0. But we know our what? Z to be what? 1 over 3. So equal to 0. Our y is equal to what? It's equal to 5 over 3. Our y is equal to 5 over 3. Now let's look for our x. So our x, use row 1. From row 1 you have what? X plus 0y minus what? Z. Minus z is equal to 3. X minus, we know z to be what? 1 over 3. 1 over 3 is equal to what? 3. And we know x to be equal to 3 plus 1 over 3. And that gives us what? 10 over 3. So our x is equals to what? 10 over 3. And this is the answer for x. So we'll say that x, y, z is equal to, have our x to be 10 over 3, our y to be equal to 5 over 3, and our z to be 1 over 3. Y to be 1 over 3 is the answer for the system, the values of x, y, z. So this is the answer. Like I said, this is the answer for our solution. Now when you get to this area, when you get to this matrix, that is where you use the back, before you use the back substitution method, we call this matrix, this is the definite solution matrix. This matrix tells you whether the solution is definite or it is having infinitely many solutions. So this is a finite solution matrix. This is a finite because you have some value here. Now there are cases where this value is also equal to 0, and you cannot say that 0z is equal to minus 1. 0z is equal to minus 1. And these are the last example we shall look at is the last. We'll talk about this equation. So when this becomes 0, then we say the matrix or the system has many solutions. It have infinitely many solutions. And how do you go about that? So this is one of the equations that has the infinitely many solutions. We want to look at this one. So this is a system given to us. X2y minus 3z is equal to 3 minus 2x minus 5y plus 4z equals to 5, and minus 5x minus 13y plus 9z is equal to what? 18. These are three equations, and it's a system. So the next thing you do is you find or you write it in augmented matrix form. You write it in augmented matrix form. Now if you write it in the augmented matrix form, this is the matrix we're going to get. And since the first item or the first element in the first row is 1, you don't need to do anything to it. Again. So what you do is you say row 2. We now look for our new values or new rows. The new row 2 and row 3, because we want to change this value to 0, this value to 0. We want to change that value to 0 and that value to 0. So we'll say that row 2 is equal to row 2 plus the new row 2 plus 2 row 1. You multiply since here is negative, if you multiply this one by 2, this row by 2, you add them, here will be 0. And then since here is minus 5 and it is negative, and here is 1 positive, if you multiply 5 by the row 2, if you multiply 5 by row 2, if you multiply 5 by row 1, let's multiply 5 by row 1, and we're going to get this value to 0. We're going to get that value 0. So that is what we did. Row 3 is our new row 3 is equal to row 3, the old row 3 plus 5 row 1. And when we did that, this plus this, when we did that, we had this to be 0, minus 1, minus 2, 11, and this is what we had. So we continue. This is what we are going to work with reference to. It is negative, so we have to change it to positive 1. It is negative 1. We want 1 to be here. Whatever you do to get 1 to be here, you have to do. And try to avoid fractions. You can only use fraction if there is no any other thing. Avoid fractions in the matrix. It becomes very difficult for your solution. So we just multiply the row 2 by negative 1 to get you multiply it by negative 1 to get a positive value here. So when we multiplied it, this is what we got. We had a positive value here, and then a positive value here to here is minus 2, and then this will be minus 11. Then this one we maintained it. I could have just do something here. I could have just, because 3 is a factor here, I could have just divide through by 3 to get minus 1, and the solution becomes simple. But you still get the same answer. Whatever you do, you still get the same answer. But you realize that if I solve this thing, row 3 is equal to row 3, our new row 3 is equal to O row 3 plus what? 3 times O row 1. So if you multiply 3 by this becomes 0. If you multiply 3 by this, here also becomes what? 0. And then this. So you realize that this is the matrix we have. Now this is 0. So you cannot say 0z is equal to 33. It doesn't make sense. So from here we call it what? Infinitely many solutions. The system has infinitely many solutions. Infinitely many solutions. It means that z could be anything. So if you pick z to be 33, you are right, but you get big values. So mostly you see books picking z to be what? To be variables. So I said let z equal to t. Let z equal to t. So it means that our z is equal to what? T. So we use what? The second row 3, the second row 2 to get our y. So y plus what? 2z. This one, y plus 2z. Y plus 2z is equal to minus 11, but we know z to be t. Substitute it inside, and then your y is equal to minus 11 minus 2t. But mostly some books also use t to be 1. They always pick t to be 1. If you pick z to be 1, if you pick z to be 1, here would have been 1. This would have been what? Minus 11 minus 2, which would be minus 13. But I decided to make it t, so let me be. We are all right. So the next one is we find our x. Then to find your x, use row what? 1. So it is what? X plus what? 2y minus 3z is equal to 3. That is what I did here. And after solving it, you're going to get your x to be 25 plus 7t. So you say that your x, y, z is equal to this. You can say let t equal to 1, and you are going to get whatever. So it is what? 25 plus 7t, then minus 11 minus 2t, and then t. If I make t equal to 1 or z equal to 1, this will be the same as 25 plus what? 7 is what? 30. 25 plus 7 is 32. Then minus 11 minus 2t would have been minus 13. Then 1. This would have been my answers, and we'll probably all be correct. We are all correct using anything. Thank you very much for watching my video to the end. God bless you so much, and please, like I said, subscribe to my YouTube channel if you haven't, and kindly turn on your notification bell to receive my new videos anytime I release or upload a new video. Thank you. God bless you so much. I'm out.